Good morning, students. We continue from page number 4, Coulomb's law. What we discussed last time, we introduced the equation F is 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. We know the terms Q1 and Q2 are the charges, R is the distance between the charges, F is the force between the charges. 1 upon 4 pi epsilon 0 is 9 into 10 raised to 9 SI unit. The unit of charge is coulomb, unit of force is Newton, unit of distance is meter. How to define 1 coulomb? 1 coulomb we want to introduce. For that we assume the charges are both equal to 1 coulomb. Possible. Let us assume Q1 equal to Q2 is equal to 1 coulomb. Possible. So our Q1 will become 1 coulomb, Q2 will become 1 coulomb placed in air. Assume distance R is also 1 meter. Possible. R is going to be 1 meter. Situation: 2 point charges, 1 coulomb each, separated in air by distance of 1 meter. Using this formula, can you calculate the force? Definitely possible. For all of you, force is equal to 9 into 10 raised to 9. Q1 into Q2 is 1. Upon R square is also 1. So that is 9 into 10 raised to 9 Newton. Remember, the situation is 2 charges of 1 coulomb separated by 1 meter in vacuum, experiencing a force of repulsion of 9 into 10 raised to 9 Newton. That gives an idea of 1 coulomb. By looking at this force, everybody follows it is a tremendous high force, large amount of force. If we compare to the gravitational force, the electric force is much larger. We say F electric force and the gravitational force F gravitational. So compared to the two, which one is larger? Gravitational force due to gravitational force of attraction. Electric force may be a force of attraction of repulsion. Since the constant of proportionality is very large, the electric force is much larger than gravitational force. So can we give one difference between electric force and gravitational force? Yes, electric force is much larger than gravitational force. Another point, gravitational force is always attractive. What about electric force? It can be attractive or it can be repulsive. Then if the idea of 1 coulomb is, you don't want to study the by heart the equation or something. 1 coulomb of charge is that amount of charge when placed from a similar and equal charge separated by 1 meter in vacuum experiences a force of 9 into 10 raised to 9 Newton. Usually in the problems and all, 1 coulomb is a very large charge. Usually we come across 10 raised to minus 3 coulomb, we say millicoulomb. 10 raised to minus 6 coulomb, we say microcoulomb. 10 raised to minus 9 coulomb, we say nanocoulomb, etc. Then we start the problem, we'll come across that. That is idea about 1 coulomb, that idea, concept, and which force is larger. Now we want to go for the how to represent this force in vector form. Next point, continuation, page number 4, Coulomb force in vector form. The answer is at the end of the page number 4, the last, only that equation we want to understand. We know the forces are equal and opposite, but you can show mathematically that they are actually true, that forces are equal and opposite. We make use of the same formula, force F. If I represent as a vector, I say force F vector, vector to the right. In this case, force F, vector to the left. But how to distinguish force acting on Q1 and force acting on Q2? We use a notation. The force acting on the first charge, I write it as F1. That is justified, right? The force acting on the first charge is F1. It is due to the presence of the second charge. So I say F12. Since it is a vector, I write vector F12. Can we say what is F12 vector stands for? It is the force acting on Q1 due to charge Q2. Is it sensible? Force acting on the charge Q1, F1, because of the charge Q2, I write as F12. Similarly, can we write what is the force acting on charge Q2? Logically, I can ask you, force acting on the second charge will be F2. It is due to the first charge 1, so I say F21. So, shall I say what is F21? Is the force acting on charge Q2 due to the charge Q1. Correct? Then we studied about a unit vector. If R is a vector, I represent this way. If a unit vector means whose magnitude is going to be 1, we put a cap like this, we say R cap. So R cap means a unit vector in the direction of given direction R. We want a vector in the direction to the right. I write it as R cap to the right. How we represent? A unit vector pointing to the right from the left. The notation is unit vector pointing to the charge Q2 to the right. From the charge Q1, R21 cap. Repeat, R21 cap is a unit vector pointing from charge Q1 to charge Q2. We can remember this way, R21 cap, unit vector pointing to charge Q2 from charge Q1. What is the direction of R21 cap, F21 cap? R21 cap and the force F21 both are going to be same. So I can say, write the expression for in vector form means force F is 1 upon 4 pi epsilon 0 Q1 Q2 upon R squared. No problem. I want to make it as a vector. What I must do? I must multiply by a unit vector. I multiply by a unit vector, then this becomes a vector. I want the force F21. So I write here F21, that is to the right. Force acting on second charge is the first one. R21 cap in the same direction, so I write it as R21 cap. What is R21 cap? Already mentioned. Then if this is R21 cap, I can keep it as R, or I can say R21. R21 is distance between 2 and 1. Same way, R12 or R21. This is the equation given at the end of the page number 4. This we say Coulomb's law in vector form. So this is the Coulomb's law. Equation is there. Express it in vector form means just write the equation and say what the terms are. So what is our understanding? I write the force. If I want a unit vector, multiply by R cap, and then this will become a force. If the force is F21, this is to the right, the unit vector must be R21 cap. Yes, we want only the equation. Just go through it once, we will be able to follow. We want only the equation. Those who can understand must be able to see the force acting on F12. Can you try? Force acting on first one. F will be 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. No problem. How to make it a vector? I must multiply by a unit vector. So I multiply by unit vector. So this becomes a force. Then how to distinguish the force? Force F12. Then what should be this? R12 is a unit vector. R12 is a unit vector in the opposite direction. So I multiply by, instead of R21, R12. Can we say what is R12? Where R12 is unit vector. What is the direction? pointing to Q1 from where? From Q2. So F12 vector will be 1 upon 4 pi epsilon 0 Q1 Q2 upon R square into R12. Just to avoid the confusion, this also I write R12. So this is going to be, when I compare the two, what I can see, R21 cap unit vector to the right, R1 cap unit vector to the left. So what is the conclusion from here? The two forces are equal and opposite. What we see? F21 force is to the right, F12 force is to the left, but what about the direction? Opposite. I put a minus sign. What is the meaning of that? The two forces are equal and opposite. The force acting here 10 Newton, force acting here 10 Newton, they are in the opposite direction. So we just, for the exam point of view, we found only the equation. Write the equation in vector form. I sum up and write the equation. This is straight the equation, the mathematical expression for the formula. Everybody knows this is the formula. Express it in vector form. Today's discussion, only one equation. That means F will be 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. I want to write in a vector form. I can select F12 or F21. I must multiply by R cap. So this becomes a force. Then if I want 21, I write F21. This will be R21. Just for, similarity, just for avoid confusion, this also we write R21. So what is F21? Force in vector form. What is R21? Distance between 2 and 1 or 1 and 2. What is R21 cap? Unit vector pointing to charge Q2 from Q1. Or we can write the other one, F12. Will I be able to write F12? 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. How you write F12? Simply put F12 multiplied by R12. This also makes R12. Just state the equation. So exam point of view, what we discuss is, today's last 10 minutes, what we discuss is, state the expression in vector form. Just go through that and just try to identify the equation at the end of the page and just try to understand what it stands for. We proceed up the next section. Thanks.